We are going to do an overview of the JavaScript material today. So first up, I want to talk about kind of just big picture about JavaScript, and then we are going to dive in and look at some specific code. There are some reasons that we would choose to use JavaScript over another programming language. And here are four very important reasons. So first up, JavaScript is run on the client side, meaning in your browser. You visit a website, the JavaScript is executed in your browser. This is great for us because it takes that work off of the server. That makes things much quicker because we're not waiting for the server to respond to process that script. Also, JavaScript is event-driven. So events are ways that you interact with the web page. JavaScript is looking for those. It's watching those. And when it sees that you perform one of those events, it can take action accordingly. Now, of course, we have to write our code and tell it what to do, but it can very easily tap into the ways users interact with the browser. Third, JavaScript is platform independent. These days, it runs pretty much everywhere, so we don't have to ask our users to install special plugins. They can just run it out of the box on nearly every device. The last one, we are not going to go in depth here, but I do want to give you a big picture about what these objects are. So an object is something that we can describe in terms of both what it looks like, those are its attributes, and the actions that it can take, those are its methods. So if you look around your room right now, you are surrounded by objects. Let's look at your computer. All computers have similar ways we could describe them. They have screens, they have keyboards, they have a mouse. So I have no idea what your computer looks like, but I know in abstract terms, those are its general attributes. All computers also have methods, meaning actions they can perform that they all share. They can all power on. They can all power off. They can all run programs, right? So for each specific computer, exactly what that looks like might look a little bit different for both attributes and methods, but all computer objects share very similar set of abstracted qualities. Think about absolutely any object you're looking at in your room, compare it to other similar things, and you can describe it in that same way. This is very helpful for us in programming because it makes it much quicker and faster to mass produce things. Just like in the real world, computers are easier when we build 5,000 of the same computer versus 5,000 unique individual computers. In programming, if we need to replicate something over and over and over that has a shared set of attributes and methods, objects help us to do that very well. Next up, now that we have the big picture, let's talk about how do we actually write some JavaScript. The first thing that you want to pay attention to are our script tags. Now this is an element that tells the document, our HTML document, interpret what is inside of these opening, which I've got highlighted here, and closing tags, which is what we've got highlighted here. Interpret this as JavaScript, not HTML. So these are always our clue that we are looking at JavaScript code, not HTML code. There are several places that we can then place our script tags. The first is our external script. So this means there is a secondary file. In this case, my file is named myscript.js. It's a JavaScript file saved somewhere on my server, and I am just pointing to it. This is very beneficial working with a large website. So maybe I need to run this JavaScript on every page of my website, and I have 500 pages. I just link each of the 500 pages to this one JavaScript file, and they all can access and use that code. Now later on down the line when I need to update that code, now I'm only making changes in one place and everything else automatically gets those changes. This is much like what you've also seen in the course when we work with an external CSS file where we write all of our CSS code in that .css file, and then our HTML pages link to that file. Very similar concept. We also have the option to embed our scripts. This is when we put the script in one single page, and all of the code that we're going to run in this video is done embedded. Now this is beneficial when I just want to perform it on one page of the site. So here I have my script tags. Again, that's my clue. And then whatever JavaScript commands I want to use go inside the script tags, and it will work for this one single page. If I want to run the code on another page, I would have to put another copy of that code on that other page. Finally, we have inline scripts. So inline means in the line with an HTML element. So here is an HTML button element. It has an onClick attribute. This is an event handler. So it is looking for the user event of clicking the button. And on that click, when that happens, it is going to execute the code within these quotations here. The key thing you want to think about with inline scripts, to be considered a true inline script, it must perform the entire action in line. So this is an example of an inline script. This is an alert, which we'll look at in a little bit, that pops up a message to the user. It is a complete piece of code all by itself. It doesn't have to reference anything else to work. Now, if my code here needed to reference something else, it would not be considered true inline scripting. It's a reference to something that would be embedded or to something that's in an external script. So it's a reference otherwhere. If there's no reference involved, like this, that makes it the inline script. Next up, we are going to talk about variables. This is the core concept behind programming. And if we want to continue to use things throughout our program, we need a way of saving it so that we can reference it later on. We do that with a variable. So a variable is just a named piece of memory. And there are a few rules to know about how we create and name these. For the creation part, we need to be on the lookout for this var keyword. That is our keyword telling us I am creating a variable, and then I will name it. So I get to come up with my own name for the variable following a couple of rules. So there are no spaces allowed. That would be one rule. The other rule is what it begins with. So the first character must be a letter, a $sign, or the underscore here. That's it. After that first character, then I can include other things, other letters. I could even include numbers in there, but the first one has to be one of those three things. The other thing to keep in mind with variables is that they are case sensitive, which is programming in general is just case sensitive. Here we have two different variables. They are both called my new variable. Now, if you notice, the first one has a capital N. This one has a lowercase n. There's also a capital V versus a lowercase v. So because the case is different, these are two unique variables. So this would probably not be a good practice to have two variables this close. It could be very confusing, but it does help us to see that we have to look out for those things. If I'm referencing and using a variable by name, it has to be an exact match to that name, or else it doesn't know what it's finding. So they are very, very exacting. So once we create a variable, then we probably want to save something to it. So these two variables here, I've created them. They are waiting for me, but I have not yet given them a value. So when we give value, there are a few different types of data we could use to save there. First are our integers. These are super straightforward. They are whole numbers, meaning no decimals. That's a different type of data. We are just working with whole numbers, and we use them like math. So here we have an alert, and it's going to alert the value of my new variable times 3. So we see my new variable on the previous line is 7. So this alert would display 21. Very straightforward math. Our next type of data is a string. These take a little bit more getting used to. So they are a string or a collection of characters, which could be anything on your keyboard. It could be letters, numbers, special characters, punctuation, spaces. Any of those characters could be part of a string. And because there's such a wide variety of what we could include in there, we designate and recognize that we are looking at a string value, string data type, because it must be surrounded in quotes. Now, we can use either double quotes or we could use single quotes. Both are fine as long as the quote we begin with matches the one we end with. So down here's our example. We start with the double quote. We end with the double quote. Perfect. The second example, we start with a single quote. We end with a single quote. Again, perfect because they match up. You might be wondering, why would we need both of these as options? Here's a quick example why that might be. This string value begins with a double quote, and inside of it, you'll notice there is a single quote here, and another single quote here. So by surrounding my string value that contains single quotes, I surround it in double quotes, it works. It can use the single quotes inside of it. There are no issues. If I had surrounded this in single quotes, I would get some errors because it would not know how to interpret that this way. So there are other ways we can work around it and put single quotes inside of single quotes, but you don't need to worry about those. Just know mixing them up in this way, surrounding singles with doubles or vice versa, is an easy way to make it work. Our final data type is our Boolean value. Think of this as a light switch. It can only go one of two ways. It can be true, it can be false. We use these a lot for making decisions in a program, so we might decide to do something if something is true, or do something if something is false, but that's all they can be. You'll notice that these true and false values do not have quotes around them. That's how I know it is a Boolean, because it is lacking the quotes. That means it is a true Boolean value, or in this case, a false Boolean value. These are our basic types of data, and next we're going to look at how we can start to use these and build a little bit and talk about some of JavaScript's built-in methods. Our first method is the alert. And as I load this page, you will see a message up here that tells me, so glad you're learning JavaScript. And my page in the background is just spinning. It's waiting on me. See, it's trying to load, but it cannot complete. It is waiting for me to acknowledge this message. So the alert is there to allow us to provide the user a message. They have to acknowledge it. Then they can move on, do what they want to do next. This is the code that created that box that made me wait and hit the OK. So it starts with alert, because that's the name of this method, and then my parentheses, opening and closing, and within the parentheses, I put the message that I want to give the user as a string value. Again, I know that because it's surrounded by the double quotes. So any message I want to put, I just put in here as a string value. It will load, it will pop up just like we saw there. Our next method is the confirm method, and here I am getting prompted for my name. My name is Jessica, so I'll type that in and hit OK. You'll notice again the page is waiting for me. I have to do something before the page can load and keep moving. So I hit OK. I get another box welcoming by name, welcome Jessica. And then when I hit OK, my page can finish loading. So let's talk about the code that made those two boxes work. The prompt, so this part highlighted here, is what created the first box that asked me for my name. So I can see in here, here's the question that I saw, what is your name? There is a second value, and prompt needs two pieces of information. The first is the message. What do you want to tell or ask the user? The second is a default value. You don't have to have a message here, but you could, and the default value would go inside of the text box by default. So in this case, I'm asking for a name, but what if the user is feeling lazy and they don't want to type their name? Maybe I have a default value that just says friend, and then the rest of my code doesn't look weird because it would say welcome friend instead of welcome empty space. But I don't have to have it. An empty string will suffice. That's what we used here. That means there was no default. Now, this asks for a name, and it is going to return back to us whatever the user enters in that box. When it returns it, is going to be saved or assigned to this variable. I know that because this equal sign is my assignment. So this variable's value will be assigned whatever the user enters in the prompt. And I'm saving it here so that I can use it. Remember, that's why we use our variable, to access this later on. Now I did a couple of things with this, just so we can start to see how the pieces connect together and how we could use data in a lot of different ways. So the first one we saw pop up, that second box that came up was an alert box that welcomed me by name. I typed in Jessica and I got another alert that said welcome Jessica. I got that because of this. My alert contains that reference to the variable username. That's what allows me to customize that message. I also added here something new we haven't talked about yet, the document write. It does exactly what it sounds like. It writes something to the document, which in this case means the web page. So I gave it a message, again, just a welcome plus the username and a period. And we see it down here in the blue box. Now I made this blue with some CSS just so we could see what we're looking at here. But I wanted you to see how we have a lot of options to work with our web page, to work with our data with these basic methods. Our next method is the confirm method. So I get a question, do you agree to the terms? And I have two options. I must choose one to move on. So I'm going to hit OK. And when I hit OK, let's look at this piece first. It's saving that my answer was true because I hit OK. So here's what we did to make all this magic happen. My confirm was the question. Confirm will always return a value. It will either return true or false. So that means we are returning a Boolean value, which here I chose to assign to a variable called answer. Then I used a document write statement just like before to write out my message, agreed to the terms, and then the user's answer. So remember, I hit the OK. My answer is recorded as true. Let's reload this page. And I'm going to this time hit cancel. And you'll see that my answer now is recorded as false. So it is a great way to document and require your user to acknowledge something, give permission in this case, and we could have a record saved that they agreed to that. Now, these three methods we've looked at are built-in methods in JavaScript, meaning they are predefined to do what they do, the things we just watched happen here. We can also create custom functions that do whatever we want them to do. And that's what we're going to talk about next. So a function is just a piece of code that is named and it's saved, and I can run that code as many times I want to, but I only have to write it once. So it helps to save a lot of time because I don't have to write this code over and over and over. I can just write it once and then use it as often as I want to. Functions hang out in memory and wait for us to call them and ask them to run. So this function here is hanging out right now. It's not going to run all by itself. Much like your computer probably has many programs installed on it, and they are not all running right now, right? You have to go and find it and ask it to run before that program will open up on your computer. Functions work very similar to that. Now, functions can be very helpful, and this is a very basic example. It takes no input, it produces no output, and we're going to build and talk about those two pieces in just a minute. But this is the core syntax, how we create a function. We start with the keyword function, tells us we're creating a function. Thanks for being helpful, JavaScript. Then we name our function. This follows the same rules as naming a variable. Next, we have our parentheses, which must be here. Even though these parentheses have nothing inside of them right now, I still must have them. We'll talk in a minute about what could go inside of them. And then I have my curly bracket. So my opening curly bracket down to my closing curly bracket. And this tells me this is the function. Anything inside of the curly brackets is the function. These are the commands that will run when we ask the function to run. In this case, I have one command. I just have an alert to tell me hello friend. As I mentioned, this piece of code by itself will not run. We need another piece to make that happen. And that other piece is a calling statement. So calling statement just means I'm asking the function to run. Please execute at this time. And we do that by calling the function by name. So this is the piece that is the calling statement. And I have some working code so we can watch this run down here. So we have the same function we just looked at, and then I've added a button with an on-click event handler. So again, it's looking for me to interact and click the button, and when I do, it is calling the function myGreeting. So here's my button. This is the actual code running on this page, and when I click it, I get my alert message that says, "Hello, friend." Next, we can start to make this more useful. This example is not super helpful, right? It's a lot of extra effort just to have an alert message. Why would I want to have the same alert message multiple times in a page? I would not. So let's look at some examples of where this becomes applicable. We start by incorporating input. So input is information that the function is looking for. It's looking for you to provide it with a piece of data, and then it's going to use that piece of data to do whatever we tell it to do. Our input goes within these parentheses. So earlier, remember our parentheses were empty? Back up here, nothing in the parentheses means no input. Now I've added one. I've added name here. So it's looking for one piece of data, and when it receives that, it will call that piece of data name. So the reference here, name, we can think of this like a variable that only the function can use. This references whatever piece of data I give it when I call the function. This is where things start to get really interesting, because now I have this one function that can produce very different things each time I call it based on the value that I gave it. If you could imagine, math would be a great example, but I know many people, including myself, our brains shut down when we see math equations. But if I had a math equation here, my input could be a different number, and each time that would solve that equation using that number would give me a different final value, right? So it can become very, very useful. So very similar to what we had before, we have our same button, but this time when I am calling the function, I'm giving it a value. I'm giving it a name as a string value. So this time I call it, I'm giving it the name Julia. And this time when I call it, I'm giving it the name Grace. And I've got two buttons up here now that go with the code. So I'm going to click for Julia, and I get my message that says, "Hello, Julia." Close that. Now I can click for Grace, and I get the message, "Hello, Grace." So it's customizing it by using that input. The final piece that we have with our functions is our output. Now I mentioned that these functions produce no output, and you might have been scratching your head a little bit because, hello, we are seeing an alert box up here. Why is that not an output? It's not. In programming, output means something very specific, and here's my way to think about it. If I tell you that I am really hungry for a cupcake, and you email me a picture of this beautiful cupcake, that is not what I want. That does not satisfy my desire for a cupcake because I cannot eat a picture. A picture just allows me to see a representation of something, much like an alert message lets me see something going on in the program, but it's not anything I can manipulate. I see the message, I acknowledge it, and then it disappears. Output in programming terms means we are giving back a tangible value. So again, if I said, "I really want a cupcake," and you came to my house and handed me a cupcake, that is output. Now I'm holding a tangible thing in my hand, and I can choose what I want to do with it. I might choose to eat it. I might choose to share it with you, but the choice is mine because I have a tangible object there. So in programming, output can only be defined with one word, the word return. Return means output, and then I tell it specifically what to output. So return greeting, the output of this function is going to be whatever the value of greeting is at this time. And that is what I'm going to give back in a tangible way so that I can choose what to do with it. So let's break down the rest of this code here. So before we had our alert with our customized message, here's the same message, but instead of being an alert, I'm saving it or assigning it to a variable called greeting. and then I am returning the value of greeting back. So outside of the function, I have another variable, my new greeting, and its value will be the output of running this function using the value of grace for input. So this needs to run before my new greeting can have a value. I need to run this, see what the output is, and that output becomes the value of my new greeting. So I pass in the name Grace. It will say hello, Grace, exclamation point, and then it will return that string value back. So my new greetings value here would be hello, Grace, exclamation point. By saving it to a variable, then I again can choose what I want to do with it. I've saved it, I can modify it, I can manipulate it, the choice is mine. So just to illustrate, I have an alert box and it is going to alert my new greeting, which we just solved, plus another sentence. It is great to see you. So let's run this and see it in action. So here is my alert box, which comes from this line here, and it says, hello, Grace, it is great to see you. So it's adding those two pieces together. Let's talk about the scope of a variable, meaning when and where is a variable available to us within the program. So there's two types of variable scope. One is global, and this means we can always see and access that variable from any point in the program. Local variables are only sometimes available to us. And we're going to look at some examples so we can see when each of these would occur, what would happen when they do, and I'll give you some takeaways to be on the lookout for. So our very first example, I call this following the rules. And what I mean by that is when we create our variables, we always use the var keyword. That's the rule. We are supposed to use this keyword to tell JavaScript this is a variable. So in this example, we've done that. We've created this variable welcome. Welcome, you'll notice, is not inside of a function. It is global. So we can always see the variable welcome. We've also created a couple of variables here, message and greeting. Both of these, again, have their keyword, and both of these are local variables. That means they were created inside of a function. They are only accessible while we are inside of the function. So if we try to do this and run an alert from outside the function, and I know this is outside the function because the curly brackets have closed up here. So if I try to access a local variable outside of that function, what do you think might happen? Let's run it and see. So our alert says undefined, which is JavaScript's way of saying, I don't know what you're looking for. You say message, I don't see a variable called message. That has not yet been defined. So undefined is what we get back. So if we try to access the local from outside, we can't see it. Now, another thing I want to look at with this, and I changed this code up just a little bit, is can we see the global variable from inside the function? We can. Remember, they're always available. There's no time we can't see a global. So in this case, I changed the code just a little bit, and now we have this alert box, and it's going to alert greeting, which is our local variable on the line above us, and welcome, which is our global variable from way up here. So the function is asking for a global variable, and it works for us. So global, I can always see it. Local, I can only see it while I'm inside of the function, right? While I'm inside the function, I can see greeting, and I get my hello Jessica, but then I can also see welcome to the webinar, which was the global variable. So then what happens if we don't follow the rules, if we forget to include that keyword var? So here's what happens. So in this piece of code, I have forgotten to use that keyword for my variable message. Now in some languages, the program will just shut down. It will throw an error. You will have to go fix the error before you can finish running the program. But JavaScript tries to help us out. It says, okay, it looks like you're trying to make a variable here, so I'm going to create one for you. But that variable is going to be a global variable. Doesn't matter where you created it. If you ever leave off the keyword, it is a global variable. So I still have this one inside of the function, but it is global. So when we now run the alert from outside of the function, we see the value of that variable, the hello, the comma, the space. Okay, so following the rules, inside of a function it's local, outside it's out. Breaking the rules, it's always a global variable. Now there is a third example that they show in the course material, and I call it the elusive keyword this, because they don't explain it very well, and I wouldn't spend a lot of energy trying to master this keyword. What I would ask you to look at first with this code, yes, we've thrown on the this word, but what else has happened here that we've already talked about? We have our keyword here. We don't have our keyword here. We've left it off. So even if the this is a little confusing, we don't know what it does, we can stick with the one rule. Does it have the VAR or not? This one doesn't. This example is a global variable. Okay? So it will run exactly the same way as the one right before it, where we were just not having the this dot part. So the this dot really doesn't change anything for us. If you stick with looking for the VAR keyword, you'll be able to see these. And there are 3 examples very similar to these in the practice test with the blue and the green alert boxes. One thing I would suggest is when you come across those, if you're having trouble with them, take a screenshot of each one so that you can see them side by side. And if we look at these 3 side by side, you'll notice there's only one line that's changed, and that's also true for those practice test questions. But changing the one line, and very specifically just changing what precedes the variable, changes the outcome of those. So hopefully this helped to kind of know what to look for. 2 things with variable scope. Number 1, did we make the variable inside a function or outside of a function? Number 2, did we follow the rules or not? Did we include that keyword VAR or not? If you stick with both of those, hopefully you can figure out where we can access things and what we're able to see at any given time. Hopefully this helped, but if there's anything that I can do to assist, please let me or one of my teammates know.